6.4, the quadratic formula. So let's recall perfect square trinomials. These are expressions in the form a squared plus or minus 2ab plus b squared. And this is what a squared minus a plus b expands to. So if we were to expand this, it would create a perfect square trinomial. The other way is a minus b. Okay, so let's just complete the following table for a warm-up. Okay, so as a recall, the number in front of x squared is a, the number in front of x is b, and then the constant c. So the value of b here is 6, and the value of c is 9. Okay, just 6, 9. So what two numbers multiply to 6 add to 9? Well, x plus 3x plus 3. So we can write that in factored form. Now, negative 14 and 49. What two numbers multiply to negative 49 and add to negative 14? Well, negative 7 and 7. As you can see all the way down like this C column here, what's going to be the C column? We can root all of these numbers. Okay, so we get 18 and 81. So I get x plus 9 squared. And then I get negative 20 and 100. So then I get x minus 10 squared. Okay, so by completing the square, we can develop a formula that can be used to solve any quadratic equation in this form. Okay, so we have the quadratic formula, and the quadratic formula is actually taken, derived from if we took ax squared plus bx plus c, and we actually completed the square on this, and then isolated for x. Okay, so in the scope of this course, I'm just going to provide the formula and just state that a, b, and c are the three coefficients. So the coefficient of the x squared term, the x term, and then the constant. Okay, so when two factors are not as straightforward, we can always use the quadratic formula to find factors that are maybe like a decimal. Okay, you can also use quadratic formula to find those straightforward factors if you don't recognize them, so that's okay too. Okay, so let's go ahead and sub in numbers to this quadratic formula. Okay, so example 1, solve each equation using the quadratic formula. So we always want to start by listing a, b, and c. Okay, so we have 2, 9, and 6. And because this is on our page up here, I'm going to go ahead and just substitute in. Okay, x equals, so we have negative b, so we take b, which is 9, and it's going to be negative b. This plus minus might be one of the first times that you've seen this formally, but this is not an error, okay? We're going to branch this off afterward. And then a big root sign, b squared, so we have 9 squared, minus 4ac. Okay, and then that's all over 2a, so this is 2 times 2. And then now all we do is simplify. So on the first step, what I usually do is I just take my calculator and I go 9 squared minus 4ac. Don't forget the negative signs here. Biggest mistake students do. So 33. And then that's over 2 times 2, which is 4. Okay, so now this is simplified. Now what we're going to do is we are going to actually branch it off to the plus minus. So we're going to get x equals negative 9, and we're going to go the plus root 33 over 4, and then we're going to go x equals negative 9 minus root 33 over 4. And then all you do is you go into your calculator and you put negative 9 plus root 33 divided by 4 in your calculator, and we're going to get one of the roots to be negative 0.8. Let's go 1, 4. And then the other one, if we put in a minus, we're going to get negative 3. Okay, so negative 3.686. Okay, so there's our one x, there's our other x. Okay, in the scope of this question, you might be like, okay, what does this even mean? I'm given a formula, don't know what it means. It means one of the points is going to be plotted here, one plotted here. This one opens up, this quadratic. So it's going to be a quadratic that looks like that. It just doesn't go through two like whole numbers. Okay, let's solve for the x-intercepts of this one. Now, we need to bring over this negative 9 because we know that in order to factor, or in order to solve for x's, we need to bring over this negative 9. It becomes a positive 9, and then equate it to 0. Okay, now let's list the a, b, and c. So the a is 4, the b is negative 12, and the c is 9. So let's sub that right in. Okay, we get negative b, which negative of negative 12 is going to be positive 12, plus minus b squared. So another common mistake is that students don't put this one in brackets and then leave this as negative, but negative 12 all squared is going to be positive, okay? Minus 4ac all over 2a. Okay, so we get 12 plus minus, okay, and we're going to go, so this is going to be 144 minus, say, 16 times 9, equals 0 over 8. Okay, so here's the thing. When we root 0, we don't get the two numbers. We don't get the plus and the minus. Those will not exist. This actually just goes away, okay? So we can just simply say x equals 12 over 8. In other words, x equals 3 over 2, okay? What does this mean in the scope of a graph? This means that there is only one root, and we've seen this before. This is when the vertex lies right on the x-axis. Okay, so now let's just read this. Finding the vertex of a quadratic relation in standard form. So just to recall, to find the x-coordinate of the vertex, add the two zeros. So this would be like the axis of symmetry, right? Add the two zeros, which is r plus s, and then divide by 2. So all we're doing here is averaging them out. Okay, to find the middle. Now the zeros, so the x-intercepts of the quadratic relation here, are going to be branched off into the plus and the minus, okay? So we've seen that. So negative b plus square root of b squared minus 4ac all over 2a, and then the minus situation. So if we actually did all this work and we took the sum of these two zeros and then we divided this by 2, what's going to end up happening is, sorry, this is just the sum of the zeros. We're going to get negative b over a, and then if we divide that by 2 in order to get the axis of symmetry, there's going to be a short form way of finding the axis of symmetry, and it is negative b over 2a. So just keep this. This is just to show you how to find it, but keep this handy. As a blurb, for any quadratic relation in the form y equals ax squared plus bx plus c, the coordinate of the x-coordinate of the vertex, in other words, the axis of symmetry, is always equal to negative b over 2a. Okay, so example 1. Sketch this equation by finding the vertex and roots. So, first of all, the vertex. I can't think of two numbers that multiply to 15 and add to 8. Okay, so what I'm going to do is I am going to, let's first find the vertex, and then what we'll do, I'll scroll down, is we'll find the x-intercepts using the quadratic formula. So the vertex, the x-coordinate of the vertex is going to be negative b over 2a. Okay, so let's list these first. A equals negative 5. b equals 8, and c equals -3. So we're going to go -8 over 2 times -5. The x-coordinate of the vertex is going to be -8. Oh, I said 5, but I already did in my head. 2 times -5. So we're going to have -8 over -10. In other words, 4 over 5. Now, the y of the vertex, we can go ahead and just sub in the 4 over 5 into the equation. Okay, so this is going to be -5 times 16 over 25. So I get -16 over 5. Eight times 4 over 5, I get 32 over 5. And then -3. So I get decimal 2 or 1 over 5. So 0.2 or 1 over 5. So in other words, the vertex is going to be, I'm going to write it in both. So 0.8, 0.2, or 4 over 5, 1 over 5. Okay, so on this graph, we can plot it 0.8, 0.2, approximately right here. And we know that this is going to open down some way, but we want to find the x-intercepts first. Okay, so let's go ahead and find the x-intercepts. Okay, and we're going to go x equals -b, so we're going to go -8 plus minus b squared, so 8's positive, so this one's easy, minus 4, keep that negative sign on the a and on the c, okay, all over 2a, and then a is -5. Okay, so if we simplify this, the entire term under the bracket goes to 64 minus 4 times -5 times -3. So I get +4. And then I get, -10 on the bottom. Okay, so let's go ahead and branch this off. So if we do a root 4, I get the number 2. So we're going to go x equals -8 plus 2 over -10. And we're going to go -8 minus 2 over -10. Okay, so for the first 0, we're going to get -6 over -10, which is 6 over 10, which is 3 over 5. And we're going to get -8 minus 2, which is -10 over -10. So we're going to get 1 in that case. Okay, so here are two x-intercepts. So let's go ahead and plot them at 1 and then 3 over 5. And we can draw that parabola, and then we can label it. X-intercepts. So if you take a look at the vertex here, we get 3, 4. Okay, so 3, 4 would be somewhere in this quadrant 1. Okay, and then the leading coefficient here, this opens up. So, okay, the vertex is above the x-axis, and it opens up. So this equation is never going to have any intercepts. Now, let's talk about the next one having one x-intercept. Okay, so what, in this situation, what is the vertex? Well, it's 3, 0. So in other words, 3, 0 lands here, and then this opens up because of this leading coefficient. So it opens up. So in this one, the vertex lies on the x-axis, and then it doesn't matter if it goes up or down. That's all that matters. Vertex lies on the x-axis. So it's always going to have that one x-intercept. Okay? And C, explain why the graph of this one has two x-intercepts. Well, we have a vertex 3, -2. So if we take a look on a graph, 3, -2 is going to lie in the fourth quadrant here. And then this one opens up. So the vertex lies, let's go under the x-axis. And it opens up. So it goes through the x-axis. So it goes through the x-axis. Okay, so we just want to talk about where the vertex is and then what way it opens. So here's a little bit of a summary. For the quadratic relation written in this vertex form here, if A and K have different signs, the quadratic relation has two x-intercepts. If A and K have the same signs, it has no x-intercepts. And then if K equals 0, so this is when the vertex lies right on the x-axis, the quadratic relation will have one x-intercept. Now we're going to talk about the discriminant and how that's related to the number of roots, or like the x-intercepts. So the discriminant in the quadratic formula is just that expression under the root sign. Okay, so b squared minus 4ac. So the roots or x-intercepts are the value of x that makes a quadratic expression take on the value of 0. Okay, in other words, it's a point that's going to lie right on this x-axis, right? Taken on 0. So first let's warm up and let's fill in this chart with the a, b, and c, which are the coefficients. For simplicity, all the coefficients of a here are 1, and then we have the b and then the c, and then we're going to solve for the value of the discriminant. So for the first one here, we have 1, 7, and 12. So we have b squared minus 4ac. So I get 1. Okay, and I'm going to come back to the number of roots. Okay, 1, 8, and 16. 1, 8, 16. So b squared minus 4ac. So this is 8 squared minus 4ac. And I get 0. Okay, 1, 2, and 5. I get b squared minus 4ac. So this is 4 minus 20. I get negative 18. 1, negative 3, negative 4. B squared, and don't forget to put that b into brackets, minus 4ac. So I get 9. So 9 plus 16 is 25. Okay, and then I get 1, 4, and 4. So we get 4 squared minus 4ac. 4 squared minus, this is basically 4 squared, so I get 0. And then I get 1, 3, 5. B squared minus 4ac. So I get 9 minus 20, so I get negative 11. Okay, so if we were to think about this d value, b squared minus 4ac, in the actual expression, this is rooted. Okay, so our question to ourselves is really, can we root this number? And then is it going to give us both options of plus or minus? Is it going to give us no options, so like a 0, or can it not be rooted, which is a negative number? Okay, so 1 can be rooted. It's going to give us the plus minus option. So we're going to have 2 roots. 0 can be rooted. but there's no plus minus option. So it's only one root. Okay, root of 0 doesn't branch out. A root of a negative number, there's no roots here. Okay, you can't root a negative number. The root of a positive number, yep, we're going to branch out to plus minus, so there's going to be 2 roots. Again, root of 0, you can root 0, but it's only going to give you one answer, and then you cannot root a negative number. So, no number of roots. Okay, so how many real roots does the quadratic equation have? If the value of the discriminant is greater than 0, it's going to have 2 roots. Less than 0, that's not going to exist, right? You can't root a negative number. And equal to 0, 1 root. You may want to box this as your note. Okay, so a question might ask, without graphing, determine the number of roots of each quadratic equation has. So all we have to do is determine the discriminant. So we have a, b, and c here. So b squared minus 4ac. So we have 64 minus, and we got 4 times 3 times 5, 60. Okay, so 4 is greater than 0, therefore 2 roots. So it doesn't actually ask you what the roots are, it just asks you how many. Okay, the next one. We have a, b, and c. So b squared minus 4ac. Okay, I'm just going to go ahead and put this all into my calculator. B squared minus 4 times 16 times 25. I get 0. Okay, so we can root 0, so it definitely will have a root, but it's only going to have one root. Okay, and the last one. D equals, we have a, b, and c. B squared minus 4ac. So this is 4 minus 28. So I get negative 24. Can we root a negative number? Nope. So D is less than 0, therefore 0 roots. Sketch the graph of a quadratic relation that has 2 different real roots. So this is just a sketch. We can sketch it so that it goes through the x-axis twice and opens up, or we can sketch it that it goes through twice and opens down. Okay, and this is not restricted to being on one or the other side of the y-axis. You can put it as a mixture. Okay, one double real root, so 2 roots that are real and equal. So we're either going to have a vertex that lies on the x-axis and opens up, or on the x-axis and opens down. Okay, and then now no real roots. So above the x-axis it opens up, right? So K and A are the same sign, positive, positive, or negative, so it lies beneath the x-axis and then opens down. I think I said down for that one, and up. Okay, so let's scroll down. Find the values of k in this quadratic equation so that it has one double real root. So we know that one double real root, we get that from the discriminant equaling 0. Okay, so D equals 0. So let's go ahead and write out b squared minus 4ac. Okay, that's the discriminant. We know that the discriminant has to equal 0. And let's go ahead and sub in a, b, and c. So k squared minus 4ac. Okay, 0 equals k squared minus 16. Let's bring that over. K squared equals 16, and we're going to root it. K equals plus minus 4. Okay, we've seen this in a previous example where, say this is K, plus minus 4 is going to just be the difference of it lying, sorry, I should have do this one opening up because the leading coefficient A is 1. Okay, so this lying on the right-hand side or this lying on the left-hand side when it's factored. So this would be like 2 or -2. So there are two different possibilities.